Dear students, welcome to Tutorific classes. Today our topic of discussion will be current electricity. Now, what is current? Current, as we know, necessarily refers to something like it refers to a flow of something. And electricity, we know electricity is concerned about charge. Now, see, when I mention the term charge, we come up with two terms, that is a positive charge and a negative charge, correct? Okay. See, so what is electricity? Is it the flow of positive charge or is it the flow of negative charge? See, back in those days we did not have electron microscope, so scientists came up with this thought that electricity is probably the flow of positive charge. But with the advent of electron microscope, we came to see that it's the electrons that flow and not the protons. But still, the direction of flow of current, the direction of conventional flow of current is still chosen to be opposite to the flow of electrons. Okay. It might seem to be a bit intimidating, a bit confusing right now, but as we move on in the upcoming 1 or 2 videos, I will be getting into the depths of this topic and you will have much more conceptual clarity. Okay. For the time being, we will be considering the direction of flow of current to be opposite to the direction of flow of electrons. Okay. So, a charge, as I said, is a positive quantity or maybe a positive or negative quantity. Now, what is electric current? What is electric current? Current is represented by the letter I. So, what is basically current? Now, if you mathematically quantify current, it is basically the rate of flow of charges through a particular cross-sectional area of a conductor. Now, see, before that, what is a conductor? A conductor is basically something through which facilitates the flow of electric charges through it. Okay. Now, see. Now, if I draw a conductor out here, I am taking a cylindrical conductor for my own convenience. Okay. Now, see. Here, I am referring to a particular cross-section area. Okay. I am referring to this area, this cross-section area. Okay. So, if t is my time period, and q is the amount of charge that flows through here, then my current mathematically will be I is equals to q by t. What is q? Q is basically the net charge. Okay. So, we come up with an equation of current. This is our first equation in the chapter of current electricity. We come up with this equation, I is equals to q by t. So, current is basically the rate of flow of charges through any particular cross-sectional area. Now, sometimes you might get this I is equals to minus q by t, and this minus sign becomes a cause of pain, or it becomes incomprehensible. Why does that minus come? Why will that minus come in? Now, see, this minus here indicates direction. Okay. It's pretty easy. See, now here if you consider this conductor out here, there are two possible directions of flow of current. Either current may flow along this direction or current may flow along this direction. Okay. Suppose if I take the left hand side to be positive. Okay. I am taking the left hand side to be positive. Arbitrarily I am taking the left hand side to be positive. So, if current moves along this direction, then my I will be q by t. But if my current flows along this direction, then my I will be minus q by t, as simple as that. Okay, I hope you get it. I will be, in this case, I will be minus q by t. Okay. So, what is, like, now we need to have a unit of charge. What is unit of charge? Unit of charge is, SI unit of charge is coulomb. Okay. SI unit of charge is coulomb. Don't worry regarding copying down the notes and all. I will provide you with good quality handwritten notes in the description section of this video. Okay. So, what is one, try and understand now. So, what is coulomb? Coulomb is basically the unit of charge. So, we need to quantify 1 coulomb. So, what is 1 coulomb, or how do we state 1 coulomb? 1 coulomb of charge, coulomb is represented by C. Okay. 1 coulomb of charge is basically the total quantity of charge possessed by 6 into 10 to the power 18 electrons. So, coulomb is basically the quantity of charge possessed by 6 into 10 to the power 18 electrons. So, by simple unitary method calculations, what is the charge of 1 electron? Therefore, charge of 1 electron is 1 by 6 into 10 to the power 18, or it comes out to be 1.6 into 10 to the power minus 19 coulomb. So, what is my 1 coulomb of charge refers to 6 into 10 to the power the charge contained by 6 into 10 to the power 18 electrons. So, other way around we can see 6 into 10 to the power electrons constitute 1 coulomb. Therefore, 1 electron constitutes 1 by 6 into 10 to the power 18 coulomb, or 1.6 into 10 to the power minus 19 coulomb. Now, we have defined charge, we know time. Now, we should also be knowing the unit of I, or current. I, or current. So, now we know that a scientist named Ampere played a pivotal role in the discovery of current. So, we named the unit of current I. Unit of current was named Ampere, in short written as amp. Now, previously we had quantified or mathematically defined 1 coulomb of charge, or now we will be defining 1 ampere of electric current. So, what is 1 ampere of electric current? What is 1 ampere of electric current? 1 ampere of electric current is basically 1 C is equals to 1 amp is equals to 1 C by 1 T. If you remember the diagram which I had drawn regarding that of the conductor, again, if I choose this particular cross section area, and through this, if 1 coulomb of charge is flowing for 1 unit of time interval, then the amount of electric current that is flowing is 1 ampere. So how do we summarize? 1 ampere of current is basically 1 coulomb of charge flowing for 1 unit of time through a particular cross sectional area of the conductor. Now, 1 ampere of current generally speaks about a large amount of current. It's a good amount of current, but there are many devices which require less amounts of current. So there must be smaller units of current. What are they? 1 milliampere represented by m small m a is basically 1 into 10 to the power minus 3 ampere, and 1 microampere is basically 1 into 10 to the power minus 6 amperes. Okay. So now we have a good concept of what is current electricity, what is charge, and what are the basics of current. Now more about this topic as we go on with the lecture series. We will be covering the entire chapter like in full depth. Now if you have any questions regarding this video, please post them in the comment section. I'll try and answer all of your questions. Okay, bye, have a good day.